Hello everyone, this is Official Sendo. Today we're going on the Spark series. In this video, I'm talking about the comparison between Spark and MapReduce, and also show you an example to solve a problems which use a summarization pattern in Spark. If you like my videos, you can support me by subscribing my channel so that more audience can see my content. You also can find the code of the example in these videos and also the complete video list in video description below. So for begin with, I'm going to introduce MapReduce. One disclaimer I want to make here is for the upcoming couple slides, I don't own these slides. You can find the original slide from the source at EDX website. The course link is shown below. So how MapReduce works is it's going through a various operation, for example, map, reduce, and all the map operation result and the reduce operation result will be saved in a hard disk. Then the downside is that disk I/O is very slow. Every time you write the data into a disk and load from the disk for the next operation. So from the trends of each hardware we saw those years as the from 1955 and 2015, we can see the chart here. The blue curve is the disk charge, and the brown curve here is the memory charge as the year continues. Then, based on these trends, we can see both memory and disk have very decline curvature, which means as recent the price of memory and both disks are going much cheaper. Then, of course, on memory I/O speed is much quicker than disk. Then, so this is why people are trying to put more money in each server for the memory. Then, based on the trends, the developer of the developer of Spark, think of to doing all the I/O operations on the memory. Also, it's mainly they need to be the hard disk because you need to read HDF's data at first. However, for the later operation result, it was saved in the memory. Then, based on their evaluation, they think using memory is get 10 or 100 times faster than network and disk. Then here is the comparison sheet compared with Hadoop MapReduce with Spark. Then based on the sort rate for an class example, the Spark achieve almost 3 times faster compared with MapReduce. Then a better comparison for more details for the storage, have Hadoop MapReduce mostly use disk, and the Spark use a lot of memory, some on the disk. Hadoop MapReduce support map and reduce, and the Spark not only support MapReduce, it also support join, sample, and other operation. And Hadoop MapReduce support Java. Then the Spark support Java, Scala, and Python. So in this series, I'm mostly using Python to implement the example for PySpark. So based on the comparison, you can find that the PySpark generally have very low I/O cost, and it definitely support more operations compared with MapReduce. Okay, now let's switch to another topic. So I'm going to show you how to implement the example of the summarization pattern. So basically, summarization pattern means to group similar data together and perform an operation such as calculate a statistic, building an index, or just simply counting. So previous videos, I'm talking about word count, which is a counting problem. So right now, I'm going to give you an example for inverting index problem, which is belong to building an index category. So one example is that, so here I'm giving three text file, name file one, file two, file three. Then each file contain a sentence, and the sentence have multiple characters and split by space. So file one have alpha, beta, delta, sigma, and file two have alpha, theta, sigma, Charlie. File three has Charlie and beta. Then the motivation for this problem is we want to build an invert index, which is like at the back of some books, you also can find this invert index, which means right now for each characters we want to know what's the finance including these characters. So for alpha, we can find it in file 1.txt, and also we can find it in file 2.txt. Then for delta, it only occurs in the file 1.txt. It doesn't occur in other two files. Now I'm going to implement PySpark to solve this problem on the Google Collaboration. If you don't know how to install Google Collaboration, you can check my previous videos, which is shows in the upper and right corner. So first step, second step, and third step are just install PySpark. Then here we also input the example into generate the PySpark RDD system. So each input has been made as a pair. So the first element of the pair is the file name, and the second pair is the sentence. Then here we also using map and reduce operation to solve this problem. Then the way we use map is a little bit complex than the example in word count in my previous video. So here I'm going to show you how this map is going to do. So here we have lambda function. So x here means a pair of the input in example. So x0 basically means the file name, and x1 is mean the sentence. So to obtain all the character key in the sentence, of course we want to split this string. Then we get all the key. For the first pair, the key will be alpha, beta, delta, and sigma. Then here we regroup another new pair. The key is the character name, and x0 is file name. Then one thing we need to very be careful is that here using flat map instead of map, since if you only use map, there will be a nested list generated here. So flat can be combine all the nested lists together and flat out to the one list of all the pairs eventually. Also, there is a bracelet we need to add into the key value. This is because in later for the reduce, we will need to doing the append operation here, so that if there's not a list is a string, for instance, it will just combine two string, right? So, but actually what we want is generate a list instead of one string. So after flat map operation, we just doing the collect action, so we can see the intermediate result, which basically show alpha for file 1, and also should be see alpha for file 2 in the intermediate example. Then lastly, we are going to do a reduce to group those pairs which have the same key together. So by using x plus y for the alpha, we can generate the list for file 1 and file 2, beta for file 1 and file 3, delta is file 1, etc. So by doing this very simple operation of code, we have done this example. You can find the complete code in the video description. Then also that's all of the contents of this video. Then hopefully you like these videos. Please comment and provide your suggestion and all the topics you are interested in. Listen to me for explain. Then see you next video.